Hello and welcome everyone. I am Dr. Supriya Gupta Bani, Assistant Professor at Ramdev Baba College of Engineering and Management, Nagpur. Here I am going to discuss with you the image processing techniques with image registration. So let's begin with the topic explanations. What is the image processing technique? That theoretically and practical skills of medical image analysis where imaging modalities, segmentation, registration, image understanding and visualization, these steps are inclusion with the image processing technique. Established method and current research focuses on the understanding and using of the algorithm. What is image segmentation and medical image registration? Image registration is a fundamental task in image processing that involves aligning two or more images to a common coordinate system. By doing so, corresponding pixels in the image represents homologies points in the real world, enabling comparison and analysis of the image. One common application of image registration is in image medical imaging, where multiple scans or images of the same patients are taken over time. With variation due to differences in the time, position or other factors. Registering these images can reveal subtle charges or patterns that may be indicative of diseases, progresses of treatment efficiency. So, the progression of disease can be detected with this image registration formats. Image registration involves finding a spatial transformation that maps point in one image to corresponding points in the another image so that the image can be superimposed on each other. So, this superimposed models the spatial transformation is typically parameterized by a set of control points which are used to wrap one image to matter the another. With where we have going to wrap this image to map with the another image, the registration is a powerful tool, or image registration is a powerful tool to control the points with matching of the objects. The quality of the registration is measured by a similarity matrix, which quantifies the degree of correspondence between the images. In recent years, there have been growing interest in image registration due to the availability of advanced image modeling techniques, increasing computing power and the need of more accurate and efficient analysis of the medical images. Image registration has become a prerequisite for a wide range of medical image analysis tasks, including segmentation of anatomical structure, computer aided diagnosis, monitoring of diseases, prognosis, and surgical interventions and treatment planning. Image registration, also known as image fusion or image matching. In this process of aligning two or more images based on the image appearance, medical image registration seeks to find an optimal spatial in transformation that best align the underlying anatomical structures. Medical image registration is used in many clinical applications such as image guidance, motion tracking, segmentation, dose accumulation, image reconstruction, and so on. Medical image registration is a broad topic which can be grouped from various perspectives from input image point of view. Registration methods can be divided into unimodal and multimodal interpretation, multimodal interpretation, intra-patients and same or different day registration. If we are going to take the registration model and we are going to take inter-patients and intra-patients, for example, they have done this registration of same or different days. From deformation model point of view, registration method can be divided into rigid and affine and deformable model that perform the region of interest, that is ROI. Perspective registration method can be grouped according to anatomically sites such as brain, lung registrations and so on. From image pair dimensions, perspective registration method can be divided into 3D to 3D, 3D to 2D and 2D to 2D or 2D to 3D. Now, application of medical image registration includes but not are limited multi-modal registration for image guided surgery. For example, aligning real-time ultrasound scans to pre-operative CT or MRI scans to real-time achieve guidance in abdominal applications. Atlas based image segmentation, where the aligning new images to those carefully segmented such that the reference segmentation can be propagated to those new images. Now, longitudinal comparison of image for a given patient with a same imaging modality, for example, comparing the outcome of given cancer treatment in the patient scans over time. Now, intersubject comparison, for example, the population study of organs, shapes that includes in it. Medical image registration, that is aligning two medical images by finding an optimistic spatial transformation, plays a very important role in image guided surgery and disease diagnosis. This alignment means that the same anatomical structure or two matching image corresponding with each other spatially. One of the true purposes of medical image registration is to synthesize the associated information contained in multiple modality image, and the other is to comprehend image obtained from the same instrument at different times and position. According to the nature of the registration based registration method can be classified into majorly two categories, that is extrinsic and intrinsic model. The registration based on extrinsic registration method are often featured attached to the patient's or clinical instruments, markers, framework and artificial implantation are widely used based in the extrinsic medical image registration. Intrinsic medical image registration consider the information containing in the image as base such as the central line of vessel and the outline of bones. Intrinsic image medical imaging registration method usually fall into two categories: intensity based method and feature based method. Intensity based approach employ different measurement based on the pixel intensities, while feature based method uses distance based measurement of the feature extracted from the input image to be aligned. Feature based algorithms are widely employed because of their briefness, simplicity and low computational complexity over the intensity based methods. More importantly, multimodality registration using computer tomography, that is CT image, magnetic resonance imaging, that is MRI image, and positron emission tomography, that is PET, X-ray and other models that is medical imaging method, is the main task of medical image registration. The intensity differences among the multimodal images vary considerably due to the different image principles, which prohibits the development of intensity based registration model. The point feature used to in medical image registration because points are the most commonly used feature in clinical application. Point feature based registration means that the geometrical transformation between two images is only obtained through the characteristics of these feature points. The geometrically transformation can be classified into a rigid transformation and the non-rigid transformation according to where there are a feature deformations are coming or not. Rigid geometric transformation are often used in the registration of rigid structure such as bone. Another important application of a rigid transformation is to obtain a rough pre-registered results before a more complex and precise geometric transformation. Non-rigid geometrical transformation are usually used to finalize the precise registration or the registration of structure accomplished with the deformations. Now, here we can see that the medical image registrations has the different type of steps where we have the two types of images. The first one is fixed image and the second one is the floating image data. So, we have to convert this floating image data into fixed image, then we process this both fixed image as feature extraction portion. Now, feature point sampling we have to done where we can update with the point set of F and the point set of M. The both feature of images like fixed and rotated or floated images. Finally, after getting the points from the extraction of points, correspondence description transformation calculation when be done, then the finally optimistic geometric transformation can be done, and finally we are getting the aligned medical image with this image registration process. Typically, we refer to one of the images in the pair as the moving image and another is the fixed image. The goal is to find the correspondence that aligns the moving image into the fixed image. The transform will project the moving coordinates into the fixed coordinate spaces. The correspondence specifies the mapping between all voxels from one image to those from another images. The correspondence can be represented by a dense displacements field, that is DDF, defined as a set of replacement vector for all pixels or voxels from one image to another. By using this displacements vector, one image can be wrapped to become more similar to the another. Now, classical versus learning based methods. Image registration has been an active area of researchers for decades. Historically, image registration algorithm posed registration as an optimization problem between a given pair of moving and fixed images. In this topic, we refer these algorithms as to classical method if they are only use a pair of image as opposed to the learning based algorithm which required a separate training steps with many more pairs of training images, just like all other machine learning algorithms. In the classical registration method, a predefined transformation model, rigid or non-rigid, is iteratively optimized to minimize a similarity measure, a metric that quantifies how similar the wrapped moving images are fixed images. The similarity measure can be designed to consider only important image feature. extracted from a pre-processing steps or directly sample all the intensity values from both images. As such, we can subdivided algorithm into two subtypes. The feature based registration is going to important features in image are used to calculate transformation between the data set pairs. For example, point set registration, a type of feature widely used in many applications, find a transformation between point clouds. These type of transformation can be eliminated using iterative closest point, that could be say that ICP, or coherent point drift, that could be say that CPD, for rigid and non-rigid transformation respectively. For example, the basis of ICP is to iteratively minimize the distance between the 2-point clouds by matching the points from one set to the closest point in the another set. The transformation can be then be eliminated from the found set of corresponding points pair and repeating the process many times to update the correspondence and transformation in an alternate fashion. Now, the intensity based registration, typically medical imaging data does not come in point cloud format, but rather 2D, 3D and 4D matrices will range of intensity value at each pixel or voxel. As such, different measure can be used directly on the intensity distribution of the data of measurement of similarity between the moving and fixed image. Example of measure are crossed correlation, mutual information and simple sum square differences. These intensity based algorithm can optimize a transformation model directly using images without the feature extraction steps. Why use the deep learning for the medical image registration? Usually in the challenging for classical methods to handle real-time registration of large feature set or higher dimensions, images volumes owning their computationally intense nature, especially in the case of 3D or high dimensional non-rigid registration. So, state of the art classical method that are implemented on GPU still struggle for the real time performances for many times critical clinical applications. So, secondly, the classical algorithms are inheritedly pairwise approaches that cannot directly take into account population data statistics and relying on the well designed transformation model and valid similarity being available on and robust challenge for many real world tasks. In contrast, the computationally efficient inference and the ability to model complex non-linear transformation of learning based method have motivated the development of neural network that infer of optimal transformation from the unseen data. Many deep learning based methods are still subject to the limitation discussed with the classical model, especially those that borrow transformation model and similarity measure directly from the classical algorithm. Deep learning models are limited as inference time by how the model was trained. It is well known that deep learning model can overfit to the training data. Deep learning model can be more computationally intensive to train than classical methods and it interference. Classical algorithms have been refined for many clinical applications and still work well. In recent years, learning based image registration has been reformulated as a machine learning problem in which many pairs of moving and fixed images are passed to a machine learning model usually a neural network. Nowadays we are using the neural network mostly to predict a transformation between a new pair of image. Now, what are the types of network output? So, we need to choose what type of network output we want to predict. Predicting a dense displacements field. So, given a pair of moving and fixed images, a registration network can be trained to output dense displacements field, that is DDF, of the same shape and the moving images. Each value in the DDF can be considered as placement of the corresponding pixel or voxel of the moving image. Therefore, the DDF defines a mapping from the moving image coordinates to the fixed image. In this point, we mainly focus on the DDF based method. Predict a static velocity field. Another option is to predict static dense velocity field, that is SVF or DVF, between a pair of image such that a diffeomorphic DDF can be numerically integrated. We refer you that the most of the details of DDF and DVF is provided by predicted a static velocity field. Now, predict an affine transformation. A more concentrated or option is to predict an affine transformation and parameterized the affine transformation matrix to 12 degree of freedom. Now, the DDF can then to compute the resample the moving information of moving image is in fixed image space. Predict a region of interest. Interest of output the transformation between coordinates given moving image, fixed image and a region of interest that should be called as ROI. In the moving image, the network can predict the ROI is fixed image directly. When multiple labels are available for each image, the label can be sampled during training such that only one label per image is used in each iteration of the data set, that is E portion. Now, here we can see the portion of neural network can handle the DDF and DVF image sets and then perform the registration. After performing the registration, we can find the final output from the source. Now, weakly supervised registration. When the intensity based loss is not appropriate for the image pair, one would like to register the training can take a pair of corresponding moving and fixed label in addition to the image pair, represented by the binary mask to compute a label dissimilarity, label based loss to derive the registration. Combined with the registration on the prediction displacements field, this forms a weakly supervised training, and illustrations of a weakly supervised DDF based registration network is provided below. When multiple labels are available for each image, the label can be sampled during training such that only one label per image is used in each iteration of the data set. Now, here we can see the form of other portion whichever use the neural network form for DDF and find the label data set there, label community here, and after considering this label data set, we are going to perform the registration with fixed and moving image, and finally we got the output as the static image. Now, we are going to combine these both methods when the data label is available, combining in intensity based label method or the deformation based losses together has shown superior registration accuracy. Compared to unsupervised and weakly supervised method, following is an illustration of a combined DDF based registration network. A note on the relationship between feature based registration and weakly supervised registration. These segmentations typically highlighting specific automatically or pathologically regions of interest, that is ROI. In the scans may also be considered a form of image features extracted manually or using automated methods. The similarity measure or distance function used in classical feature based registration method can then be used to drive the training of the weakly supervised registration network. These measures include the overlap between ROI and Euclidean distance between the ROI centroids. A key insights in that the weakly supervised learning described above, the learn the feature extraction together with the alignment of the features is an end-to-end manner. Now, what is loss function? We aim to train network to predict some transformation between a pair of image that is likely. To do this, we need to define what is the likely transformation. This is done via a loss function. The loss function defines to train a registration network will depends on the type of data we will access to. Yet another methodological details draw substantial experiences from the classical methods. Now, label based loss. What is label based loss? Provided label for the input image, a label based loss may be used to measure the dissimilarity of wrapped region of interest. Having computed a transformation between image using the net, one of the label is wrapped and compared to the ground truth image label. Labels are typically manually counted organs. Now, intensity based, that is image based loss. This type of loss measure the dissimilarity of the fixed image and wrapped moving images, which is adapted from the classical images registration method. Intensity based loss can be highly modality dependent. The common loss function are normalized cross correlation, that is NCC, sum of squared distance, that is SDD, and mutual information with their variance. Now, additionally, training may be regularized by computing the likelihood of a given displacement field. So, deformation of loss has given high deformation losses points to very unlikely displacements due to high gradients of the field. Typically, deformation losses ensure smoothness in the displacements field. For DDF, typically regularization losses are bending energy loss, L1 and L2 norms of the displacement gradients. Here, we should be able to see either or both of the following two cases. There are labels appeared in some slices of the fixed and wrapped moving images, while it does not exist in the same slices of the original moving images. Some label of the original moving images disappeared in both fixed and wrapped moving images from the same slice. Both indicates the wrapped moving image has been indeed wrapped closer to the fixed image space from the moving image. Now, I am going to conclude the whole image registration process, that two classical image registration algorithm and the deep learning registration network all imported with deep registration. To discuss this basic of modern image registration algorithm, particularly we show that the all sharp principles methodology and code between the old with the new image registration processes. Deep Registration is a new open source project that has a unique set of principles aiming the consolidated the research field of medical image registration, open, community supported and clinical application driven. It is these features that have motivated effort such as this points to communicate with wider groups of researchers and to facilitate drivers clinical appropriate and their application. These points may serve as a starting point for next generation of researchers to have a balanced starting point between the new learning based method and the classical algorithms. Now, it may also be used as a quick introduction of deep registration to those who have significant experience in deep learning and or model of medical image registration such that they can make an informed judgment whether this new tool can help these researchers. In the conclusion, we have analyzed the old or classical pattern as well as the new deep learning registrations are there. What is basically registration or image registration? After getting or acquisition all the image processor, we have to decide the pre-processing technique, then we have to apply the image registration process where in image registration you have the comparison of two models where the similar type of images can be converted in fixed and moving images. So, you have to convert this moving image in the fixed image, then we have to calculate the feature analysis at the point based. After extracting the features from both the images like static or single image or moving image, we have to combine these features and after that we have to process the image registration field. Finally, we find the registered image with the new or classical based model. So, this all lectures is going to help you to find the image medical image registration with the pattern classical as well as with the pattern of deep learning. Who has the knowledge of machine learning and deep learning patterns, they can easily access all the deep learning process with the registration with innovative and effective and efficient ideas of deep learning methods like weakly supervised, supervised and unsupervised field of registration. So, whenever we are going to use this image registration format, so we are going to perform intensity based image registration. Why we are going for intensity based registration with deep learning process? Because we have to handle high dimensionality models like 2D, 3D and 4D matrix for medical images. When we are going to use this image registration, that would be going to use for fixed image as well as rotated image. So, these are the cross relation of mutual information and simple square differences of the intensity that could be handled with 2D, 3D and 4D matrix. It could be the higher dimensional side can be handled with this image based registrations. Now, we can see that the major portion of image registration can acquire image pre-processing technique and then simple format of single and rotated images. Then the feature extraction process can be done with the deep learning processes where the deep learning processes could be highly supervised, labeled and weakly supervised with DDF form. When we find this DDF form with the trained network or pre-trained model and then we find the test outcomes from there, we have to use the combined method of like classical method and the deep learning model of registration. After finding this combined method, we will find a beautifully image registration based method for finding the registered image as your extracted feature image. So basically the image registration is the field where you can process your medical image in the form of exact, without rotational and feature extracted image that could be showing you a base image like a beautifully finded, cropped, intense values of pixels. You are going to process it further for segmentation, for valuation, for diagnosis, for treatment. So the image segmentation, image processing, image registration, so these are the process are going to help the researcher as well as the medical practitioners in their field of medical terms. So medical image can be analyzed with these processes where the image registration plays a very important role to analyze the medical images in the form of medical images. Thank you.